Analyze the chemical reaction occurring with water. When solid sodium, Na, and magnesium, Mg, metals react with water, they undergo an oxidation-reduction reaction where the neutral metal atoms lose their valence electrons to become positive ions, Na to the power plus and Mg to the power 2 plus, in solution. Identify the thermodynamic property governing electron loss. The ease with which a metal atom loses its outermost electron is directly dictated by its first ionization energy. A lower first ionization energy means less energy is required to remove the first valence electron, making oxidation thermodynamically and kinetically easier. Compare the periodic trends of Na and Mg. Sodium, group 1, and magnesium, group 2, are adjacent elements in period 3. Magnesium has a higher nuclear charge, 12 protons versus 11 protons, attracting valence electrons in the same 3 shell, which holds those electrons more tightly. Therefore, the first ionization energy of sodium is significantly less than that of magnesium. Relate ionization energy directly to reactivity. Because sodium's single valence electron is held less tightly, sodium loses its electron much more easily than magnesium does. This lower energy barrier allows sodium to react violently with water at room temperature, while magnesium reacts incredibly slowly under the same conditions. This matches option D. The correct answer is option D. The first ionization energy of Na is less than that of Mg.